Friends, welcome to follow up. Let's have a look at problem 2852, sum of remoteness of all cells. In this video, we are going to explain a solution based on the strategy of reduction of problem, and then we are going to use traversal algorithms to address this problem. So here I want to emphasize the definition of remoteness. So given a cell Ig, so we define remoteness as R, which is defined as the following. So if the cell Ig is a non-blocked cell, then the corresponding remoteness is the sum of the values grid xy. So such that there is no path from the non-blocked cell xy to the cell Ig. So in other words, xy and Ig, they belong to different connected components. So actually, if you can think of connected component, this problem is half solved. And for block cells, the corresponding remoteness is 0, right? So we want to return the sum of the remoteness over all cells, right? So here are two examples. So in the first example, if we look at 1, 5, 4, 3, so these are the 4 non-blocked cells. So for cell 1, so if we compute the sum of 3, 4, 5, so we're going to get 12. And then for cell 5, so we're going to get the sum of 1, 3, 4, that is 8, right? Now, similarly for others, then you can get all the output is 39. So we can do like this. So for example 1, so the remoteness of the value corresponding to cell C0, 1 is nothing but 5 plus 4 plus 3, right? That is, this is also the sum, the total sum, right? That is 5 plus 4 plus 3 plus 1 minus 1. So we write in such a format to hint the general case. And for R1, 0, so the remoteness is 1 plus 3 plus 4. So actually, there are still this one. So minus 5, right? So similarly, let's compute this for 1, 2, right? So this will be 1 plus 5 plus 3, which is 4 plus 5 plus 4 plus 3 plus 1 minus this value, that is minus 4, right? So similarly for 2, 1, so what we are going to have is 1 plus 5 plus 4, right? So that is 5 plus 4 plus 3 plus 1 minus this value. So this value is 3, right? So overall, the first one corresponds to 12, the second one corresponds to 8, and the third one corresponds to 9, and the fourth one corresponds to 10, right? So if you sum the 12, 8, 9, 10, you are going to get 39, right? So this is the first example digest. So hopefully from here you can get the generic case or general case. So for example 1, notice that so the 0, 1 cell and the 0, 2 cell corresponding to values 3 and 4, they are in the same cluster, right? And the cell with index 2, 0, so it's another connected component, right? So the remoteness of 3 and 4 actually are the same because they are in the same connected component. So both for them, so their remoteness is 3. So because they have 2 cells, we need to count 3 by twice, right? This is one thing. And for 3, right? So the remoteness will be 3 plus 4, that is 7. So we have 3 counted twice, that is 6. Then we have a 7, that is 6 plus 7, that is 13. So this will be the output. So now I want to write some formulas for the general case. So overall, this problem is to reduce the two find connected components. With the information for connected components, we can easily compute the sum of remoteness of all cells. So let's assume that we have found already the connected components. Let's call it this. This is connected component 1. So you can think of like this one. And this with the connected component sum, let's say S1. So C1 has a sum of S1. The sum means the greatest sum for all the cells in this connected component. And also we have N1. N is the number of cells in this connected component. So this is actually easily to retrieve from the information. And then, so we have another one, let's see, C2, S2, and N2. And in general, we have CM and SM and NM, right? So now assume that so the sum of all non-block cell is CS, right? Then we want to compute the remoteness. So basically, we want to add the remoteness of the cells within each of the connected components, right? So for cell 1, or for general cell, let's say CI for this cell. So the contribution to the final result will be, let's count how many cells in this in this connected component. And then each cell, their remoteness are the same. So the remoteness will be the sum of S1, S2 up to SM, but excluding SI. So this is nothing but S minus SI, right? Then this is for generic for a CI. Then the return will be nothing but summation over I. Summation Ni times S minus Si over all I. In other words, over all connected components, right? Connected components. So this is the generic case. Now let's look at example 2, right? So for example 2, so we have two connected components. So one is, the first one. So we have C1. So they have two cells, that is 3 and 4. Their sum is 7, and there are two cells, right? For the second connected component, so let's call it C2, right? So the sum is 3, and the cell number is 1, right? Then we compute the return. The return is nothing but, the remoteness of this one. So this is 2 times the overall sum is 7 plus 3. This is 10, right? 10 minus 7, right? 10 minus 7 is the remoteness of each cell in the C1. And then we're going to compute 1 to this one times the remoteness, that is 10 minus 3, in other words, 7. So we have 6 plus 7, that is 13. So if you arrive this far, so then coding the problem will be very simple. So next, let's do the coding. So for the coding, so let's write with some detail so that you can digest that. So actually, you can write very short code, but that's not our purpose. So first, let's get the number of rows, number of columns. So notice that the assumption this grid has the same number of rows and columns. In other words, it's a square. And then let's get non-blocked cells. So I'm going to use a set, right? And then also I want to get the total value for non-blocked blocked cells. Let's initialize it as 0. Then basically we do a for loop, right? So we can use list comprehension to get this thing, right? Very easy. But also we want to get the total sums, total value. So let's do it like this. For I in range n, for j in range n. So basically, if grade I j is non-negative 1. In other words, if it's greater than 0, right? In this problem setting. So we're going to, the total value going to be incremented by this number. And then we are going to non-blocked cells, so add this current cell, right? The reason we get this is that we are going to do traversal later. So with this block, we get two pieces of information. First, the indices or coordinates of non-blocked cells and their corresponding total value. So that is, we get this S right here. Get this S in the above explanation. So next, we want to write a function so that we can get all connected components. So this is basic traversal. Let's quickly write one based on DFS, right? So we accept a source. So this source will be a tuple, let's see, RC, the coordinates. And the return, we're going to return a set, right? A set representing the connected components. Components including containing the source. So this is actually very simple. So let's use a set to aid the traversal. And then let's use a stack. So this stack put this one as a source. And then basically a while loop, while s. So we can first do pop. Xy will be s pop, right? And then we want to check if xy are not in sim, right? Then we want to do some work. First, we add this to the set, and then we check its neighbor. So for RC in, let's write this as xy to distinguish, but it does not matter. So here, let's check this four neighbors: xy minus 1, y, x plus 1, y, and x, y minus 1, x, y plus 1, right? So we want to check several things. First, this R and C coordinate will be inbound, right? That is, if R is in this range and C also in this range. So this is one condition. This is the inbound condition, right? And we want to make sure RC are not invisited, are not in sim here. And also, we want to make sure this RC is a non-blocked cell, right? So let's use it as greater than 0. Or you can check if this RC is in this set, right? So if these three conditions hold simultaneously, then we're going to append this to the S, that is RC, right? So after this while loop, so we are going to get a set containing indices, coordinates. So this will be the representation of the connected component containing resource. But here I just return the sim. But if you want to do things in one go, you can also count the number of cells. Each time there's a new cell added to the set, we are going to increment the count by 1. But we can do it later. But here, let's isolate the things to make the idea clear. So we get this hyper function. So next, I want to get the clusters. So this will be very simple. Clusters, I'll use a list. And also, I use a visitor set to aid the overall traversal. So basically, for position in non-blocked cells, right? So I want to do traversal. So first I want to check if position not in visited, right? So we are going to do effective traversal. So go to position. And then first thing I want to do union, right? Because all the cells in C will be visited. And then I want to do clusters append the current cluster, that is C. So this way we get all the clusters like here, right? So next we want to get the sum and the counts, right? So this is actually very simple, but we can write a small function to do this. right? Get cluster sum and in cells. Let's see. We have a cluster, right? And then what we want to do is to return the sum of grid x, y. So for x, y, this is tuple, right? In cluster. And this is the one piece of information. And also we want to get the length of the cluster because cluster is a set object, right? So let's see, cluster, the set. So we want to return so the sum and also the number of cells. Right? This is the length of the cluster. So with this, actually we have prepared sufficient information for prepare the return. So next we do the return. So this is actually very simple, right? So now we have a result as 0. So then we are going to iterate over the cluster for C in clusters. And then we are going to get NS. So this will be the SI, right? For corresponding to here, right? So we get S at N cells. So this will be get, let's call it this function signature. And then we change this argument to C, right? And then what we want to do is an increment because we do submissions. We have N cells. These N cells have the same remoteness score, that is the total sum. So we have already get it. That is the total value. So minus this S. So after the cell, we just return the result variable. So this actually this completes a solution format for this problem. So before we make any further comments, let's first do a test. Yeah, it passes the first example, I guess. Now let's look at the generic case. It passes all the cases. So here, before we end this video, let me make this program more structured. First, so get non-block cells and total sum. So this is the first step. So the second step will be a helper function or utility function for traversal. So here we used depth first traversal. So this one is step 3, get connected component information, right? So the last one will be prepare the return, right? So needless to say, this code can be greatly shortened, but our purpose is not to write shortest code, but to expose the idea in a clear fashion. So with that said, basically that's about it for this video. Thank you.